I think a lot of people here today have things that explode and big objects, and which is very exciting. I unfortunately, or fortunately, I don't know how you want to frame it, have something that's extremely tiny to show you. I don't want it to fall out. This is pretty ITAR controlled, and none of you can see it from up here, making it even harder to describe how important this is. You can't see what it does either. It's invisible, its actions are invisible, it's extremely tiny, and it's decisive. Today's battle environment is extremely information dense. If I can see you and you can't see me, I can kill you faster. That information density has an open flank, and that open flank is the ability to jam, the ability to spoof, the ability to sniff out anything in that radio frequency dimension where that information is being transmitted. This is an open flank. This is a problem. Our enemies are working very hard to figure out how to attack and jam our communications, and we need to be thinking about it as well. The decisive element is this, right? This is what's going to win or lose battles. And it's extremely small. It's measured in millimeters. And if you think about what really matters, it's these incredibly difficult design problems that are happening at the nanoscale, at the electron scale. The power output, the input power, the gain, the bandwidth, the operating frequency, the instantaneous bandwidth, the linearity, the signal to noise. All of these are these important decisive elements in this kinetic battle that so many people are working on in this audience today. Unfortunately, the United States just does not graduate that many chip designers. China graduates 6 times as many as us. I don't know what the Russian numbers are, but they're probably higher than ours as well. Sphere Semi is a chip company. We design and fabricate chips that are used for military applications like electronic warfare and SIGINT. Our chips perform at competitive levels with people like Corva, with people like MACOM, with people like Skyworks who make these chips for a living. The difference between us and them is, and the reason why my 10-person team can do that is because our chips are designed entirely by AI. We can get 1/10 the area, we can get 1/4 the power consumption, and most importantly, and I think this is critical in this very fast-moving battle, we can get to market in 1/8 the time. I can go from a concept that a military needs and a warfighter needs in a military electronics to getting it out the door, and the main bottleneck is how fast Northrop Grumman wants to fab it. Just kind of going over some key facts. We're an RF company. We build RF chips. Design time we bring down, and we can get world-class specs. We're even working to have the AI push performance out beyond where the current competitors are. We are working to integrate digital components and boards so we can put an antenna on it. We can build a module, the sort of stuff you need to get a complete system. We have 2 clients right now. The first is working on an electronic warfare application with us, and the second is working on a SIGINT application with us, signals intelligence, for those who don't know. Electronic warfare, you need incredible power. You need incredible amounts of bandwidth to really win these battles, and we've been able to provide that. As well as in SIGINT, you need settling time and things like that. Speaking of clients, this is a classic situation. Our client had a board. He needed to shrink the size of the board. Area was important to him. We had got him an 8x8 package. These are packaged. They're not just die boards, by the way. We had gotten him an 8x8 package. We needed to shrink it to a 3x3 package. He wanted a civilian use case. He also needed, if anyone here is an electrical engineer, a DC-DC converter inside the package. We didn't have a lot of time to fill this requirement, and so we put our AI to work. Over a weekend, we were able to shrink the size of this chip by 55%. We were able to fit it in the package they want, include the DC-DC converter inside it, and fulfill the requirements purely by the power of AI, purely by the power of a platform that we have built natively. And here it is at work. We bring together a bit of a Frankenstein's monster of techniques, which I'm quite proud of. You can't just solve one thing with one method. All of the models are our own. We've built them all ourselves. We have a physics model in there that can do the electromagnetic simulations. This is small. Things happen here on the quantum level. We also have reinforcement learning models that are doing the search that you're seeing up here. There's a cool thing going on right over here, right? It's going from 6 resistors to 4, and it's shifting the circuit design around as it goes, as it searches to try to shrink the area. So I think that's fun. That's kind of cool. That shows how the system works. We, of course, do have humans in the loop. I have a fantastic chip design team working with us. We're moving out. We're moving up. We think that the multiplicative power of our AI system can be brought to bear much better by building on modules, by building together, integrating pieces together, whether it's antennas or board design or even the digital components that you need on the front end of these electronic warfare systems. So we're moving out, we're moving vertically upwards, and we think that that's an incredibly important thing because we want to bring as much power of the AI to the front and into the entire way that electronics are being used in electronic warfare and SIGINT today. I'm not going to speak about me because that's gauche or whatever, but my co-founder Mitch is the real brains behind this. He has an EE PhD from Princeton. He was the founder of Luminous Computing, which was building AI chips, and he founded the field of neuromorphic photonics. And we have a generally great team of AI people, chip designers, an integrated team of those people. Some of the people came from biophysics, which is really cool, kind of bringing together that knowledge that people are doing in pharmaceuticals into what we do today. I think this is a pivotal moment. You can go read it yourself, but oftentimes the Chinese write about an electronic warfare Pearl Harbor. Our enemies are thinking about this stuff. Russia today, if you go to Ukraine, Russia and Ukraine have SMT lines on the battlefield where they're reconfiguring the chips to fight the next day. This is important, and the most important element, I think, is not just getting the best chips. That's cool, that's great, but it's getting them fast. Russia and Ukraine are adapting their electronic warfare techniques every day against each other for jamming and counter-jamming and all that stuff. We face an incredible threat in the electromagnetic domain, and our allies in the United States need to be ready for it. Our first generation of chips are being tested by primes today. It's extremely exciting. We are looking for new things. We are looking for new projects. We're probably a younger company than a lot of the companies up here, and we're looking for people who want to expand their capabilities. If you are a UAV company who's looking to bring lower swap, lower area chips into your products, we're for you. If you are someone who's looking in the military for an edge in EW that you're not getting from the people out there today, we are for you. That's basically it. If you want to come look at this, by the way, you're welcome to come by and take a gander. It's very small, but you can actually see the circuits on it, so kind of cool. That's all I've got today. Please come find me. Email's right there. Happy to chat, and really, really thankful to be here today.